Okay, let's talk about statistics. And I know what you might be thinking, but stick with me. This isn't about memorizing formulas. This is about something way more important. It's intellectual self-defense. It's about learning how to see the real story that's hiding inside the numbers. A skill that is, let's be honest, absolutely essential these days.
Because here's the thing. Without the right tools, even the best data in the world can be completely confusing. You can do all the research, gather all the facts, and that brilliant idea of yours, well, it can still end up looking like a very organized mess. If you can't describe your data clearly, you can't really understand it. You're flying blind.
So how do we do that? How do we cut through all the noise and find the actual truth hiding in our data? Well, it turns out you can get most of the way there just by asking two really simple, fundamental questions about any set of numbers you come across. To turn that mess into a crystal clear picture, you really just need to find two things: the center and the scatter. First, you have to ask, what's the typical value? Where does the data tend to cluster? And second, how spread out is everything? Are all the numbers bunched up in an orderly line, or is it just total chaos? Let's start with the center. It's a really simple but powerful idea. Imagine you've got a huge pile of data points. We need to find one single number that can stand in and represent that entire group. These are called measures of central tendency. So, first things first. Our mission is to find the data's center. This is all about pinpointing that one single value that best represents the whole group.
And the most famous way to do this is the mean, what we all just call the average. A great way to think about it is like a balance point. Imagine all your data points are weights sitting on a seesaw. The mean is the exact spot you'd put the pivot to make it perfectly balanced. Every single data point gets an equal vote. It's very democratic, for better or for worse.
Okay, let's make this real. Let's say we're tracking recovery times for 5 patients after some medical procedure. In this first scenario, everything goes smoothly. The recovery times are all pretty close together. It's a nice, predictable, well-behaved set of data.
And if you calculate the mean, what do you get? 7 days. That feels right, doesn't it? It sits smack in the middle, and it seems to perfectly capture the typical experience for this group. So far, so good.
But here's where the main's greatest strength, its democracy, becomes its biggest weakness. What happens if things don't go smoothly for one of those patients? What if one person has a major complication? Let's just say one patient takes a lot longer to recover. We're talking 80 days. This crazy value way out on its own is what we call an outlier. It just doesn't fit in with the rest of the group.
Now look what happens. Our new mean skyrockets all the way to 21.2 days. That one single patient who took 80 days has dragged the entire average way over. Now, does 21 days, 3 weeks, really represent the typical recovery time for this group? No way. 4 out of the 5 patients were better in about a week.
And this shows the danger perfectly. A number can be 100% mathematically correct, but in the real world, it can be, as the source puts it, therapeutically misleading. It no longer tells you what's actually happening for most people, and a bad average can lead to some really bad decisions.
So when the mean gets bullied around by these outliers, we need to call in its partner, the median. And the median is awesome because it's so simple and tough. It doesn't care about extremes. You just line up all your data from smallest to largest, and you pick the one that's physically in the middle. That's it. It's not easily impressed. So let's go back to our weird recovery data. We line them up, 5, 6, 7, 8, and then way out there, 80. Well, what's the number that's still sitting right in the middle of the line? It's still 7. The median is completely unfazed by that 80-day outlier. It gives us a much more honest picture of the typical patient. So here's the big takeaway on this. Think of them as having 2 different personalities. The mean is democratic, but it's super sensitive. It gets easily pulled around by outliers. The median, on the other hand, is robust and pragmatic. It just ignores those wild values. So you use the mean for nice symmetric data, and you trust the median when your data gets messy and skewed. Okay, so we figured out how to find the center. Awesome. But that is literally only half the story. Just knowing the typical value is not enough. We have to ask that second question. How much variation is there? How much chaos is in the data? This is what we call the spread.
To see why this is so critical, imagine we're testing 2 new drugs, drug A and drug B. They're both designed to lower blood pressure. And if you just look at the data, they seem identical. Both of them have a mean reduction of exactly 20 points. So which one should you prescribe? They're the same, right?
Well, let's peek behind the curtain at the individual results. For drug A,
The results are incredibly consistent. All the patients are clustered right around that 20-point mean. It's predictable, it's reliable, you know exactly what you're going to get. It's kind of boring, in a good way.
Now look at drug B. Whoa, it has the same mean, but the results are all over the map. Some patients get a massive benefit, while others get absolutely nothing. Drug B isn't reliable at all. It's a total gamble. Clearly, that mean of 20 didn't come close to telling us the whole story. So to measure this spread, the mean has its own trusty sidekick, the standard deviation, or SD. The best way to think about it is as the average wobble around the mean. A small SD, like for drug A, means all the data is packed in tight. A huge SD, like for drug B, means the data is scattered all over the place. But you know the drill by now. What happens if our data's skewed? Just like the mean, the standard deviation can get totally thrown off by outliers. So, of course, the median has its own partner for measuring spread, the interquartile range, or IQR. And it's really clever. It just measures the spread of the middle 50% of the data, completely ignoring the crazy extremes at either end.
And all of this brings us to the grand finale, the big takeaway. It's all about finding the perfect pair. If you can remember this one fundamental rule, you'll be able to see through misleading data for the rest of your life. It's all about pairing the right tools for the job.
It's this simple. For nice, symmetric, well-behaved data, you report the mean, and its partner, the standard deviation. But for skewed data that has outliers, you report the median, with its partner, the interquartile range. They are a team. Mean goes with SD, median goes with IQR. Mixing and matching is a huge statistical red flag.
So, from now on, the next time you see a news headline or a report that just gives you an average, you'll know better. You'll know that one number is never the full story, and you'll know to ask the most important follow-up question.
Where's the rest of the story? You'll ask, is that average a mean or a median? And then you'll ask, and what about the spread? Because now you know the truth. The scatter is just as important as the center. And that is how you find the truth, hidden in the data.